see what we built the last time. So I'm looking at this diagram that is up and I'm trying to translate it. So this is going to call a service. It knows exactly what to do when it's calling this service. This is actually the ghost service, right? So this one was the ghost service we built. So it's ghost is a service. This ghost service does only one thing. It doesn't really it goes to this container. So even within the task, the ghost itself knows which container to go to, right? So we did that. But we also said that the ghost container needed to also talk to a webhooks container. And we said one of the fast way to do it is for us to bound it to a task. So we had a task that had two containers in it, and that's exactly how it worked, okay? But if you look at it, this web ghost and this webhooks, they are actually two services that are meant to be independent. So we were not supposed to put them together in the first place, but we did that just for me to also prove a point. And, you know, we did it and it was working. Ghost is a website. It's like a blog. It does many things, but it's like a blog and all that. So what we did, we took it and then we went to Docker Hub and we said Ghost. You know, we took the container. So the container is here. We basically just took this container and then we launched it on ECS. Okay. So this diagram is exactly how we got there. Okay. And this task, we said this task is bound by task definition. Okay. So we're just going to expand this. Good. So I think now I've drawn all the diagrams that I need for us to introduce what we'll be building today. Okay. If you were here in the last class, everything we built the last class, I've put it as IAC. We don't have to go back to it again, okay? Because if we have to go back to it, we'll be spending too much time doing what we don't need to be doing. So today, we'll use everything we've built before. I'll use IAC to bring it up, and then we'll build on top of it, okay? Please ask, now is the time for you to ask questions. Because if I start building, you really need to know why we're doing something, okay? So if you have any question, ask any question you have. Also, if you've been here when we built these before, if you have any question, I think for some of you have seen the things we've built in the past. It would be nice if you can ask any question relating to what we've built. You can ask. You can ask. Let me see if there is anything in the chat. VPC endpoint, I've answered that. Mr. Agbo, if you are still on the call, you're going to see answer to that question that I told you about. Private subnet, I think I've answered that. All those details are actually abstracted. Public, private subnet, they are kind of hidden. Usually, yeah, we will not be able to be showing them all the time, okay? Let me see. Do you bootstrap for the chicken and egg situation for Terraform? It depends. It depends. I think here I'm not doing, it depends. It depends on how you are. But I know sometimes you have to more or less like, first of all, use Terraform to create like a state bucket, S3 in this case, and then it has to more or less like, yeah, there's always that chicken and egg problem, but if you have ways of, you should have ways of solving it at some point. Let's see, where are the old videos? Okay, I think I've answered that question. Okay, yeah, okay, cool. All right, I think now is a good time to start, okay? Now is a good time to start. So I'm going to explain this diagram first, explain this one that is down here, and then we'll go up and explain the other diagram, and then we'll start building, okay? So if you remember, so let's start. In the last couple of series, what we're trying to build was really what is in the middle here, right? So what we tried to build was we had an ALB that connected to a ghost service, and that ghost service was backed by a number of tasks. They have like a task definition. They are using a database, right? That's where we started from. When we built that, we now said that usually in production, or when you try to deploy applications, most times it's not one service you're dealing with. You're dealing with multiple services. So we extended that and we said that we introduced a webhook service, right? The webhook service, we built it ourselves, right? We took a small Python application that is a service, we Dockerized it, we pushed it to ECR, and then we set up a task for it, right? A task is just what runs the container. And we said that to keep it simple, what we did was that we said the ALB is going to talk to the ghost service, and the ghost service is going to talk to the ghost task. And then we said the ghost task is going to talk to another container inside the same task, right? So there was a tight coupling there. We took a task, an ECS task in this case. So this is actually ECS. Let me just add the details here. So that's whoever has seen it. There are many ways to do container orchestration in AWS, but this is ECS so that you understand it's ECS we are talking about, in case anybody joins the call and they are not. So we said that in this case, we had a task and we had two containers inside, right? But again, there was tight coupling. The reason is because it goes something that is UI driven, right? Something you see in the UI. The requirement for that kind of container will be different from something that is serving webhooks, right? So what it means is that this pattern, although it works, it's not the best pattern, right? Because in this case, we have to put two containers in one task. And for that reason, it means that every time you need a Ghost container, you also need a Webhooks container. But that's not the case. Usually, sometimes, maybe this one does not need too many containers compared to the Webhooks container, right? You can have more Ghost container or even less web. Yeah, you can have more Ghost containers or you can have more Webhook container. But the whole idea is that we're supposed to break them apart. But we said, just to keep everything short, we'll go through using one task. And that we got that working. So we said that was the quick fix of having a Ghost service talk to a different service, in this case, which is supposed to be a webhook service, but we didn't really create a service for it. So that brings us to a question. The real question we're trying to answer in this class is the fact that when you host them in the cloud, they usually need to talk to themselves, right? And that's what you call multi-service communication, right? Where one service is talking to another service, right? Or one service is talking to like 5 services. There are times where one service will call one service and get an information. From that information it got, it's going to call a different service. Usually that's how it works, right? You have multi-services talking to themselves. And solving that problem just means you introduce something new, which is called service discovery. Because if I have to talk to a different service, I need to know how to discover that service. I need to know how to find that service. I need to know how to be able to see the service I want to talk to and then talk to the service, right? Because I will not know the other service exists. There must be something that tells me that service exists before I can call the service. Okay, so we're going to be looking at our option. So this is what we did, and we said we're not, although we love it, it works, but there are better ways of going about it. And that is what I'll be introducing to you. The first one is really, when you think about it, depends. And I think we've talked about the problem we're trying to solve, multi-service communication, which means there will be service discovery at some point because you want to be able to discover other services that you can talk to. One quick option is really, you have something like a load balancer in this case, right? That can talk to multiple services behind the scene, right? So a load balancer is one of those. A lot of people use load balancers a lot, right? But this one, if you think about this approach, usually for the most part, it is like when the services themselves need to be directly interfaced with the internet, right? So maybe you have like a public ALB. So maybe I'll be specific here and say public load balancer. So this is actually public, okay? Just so you know, public, okay? So in the case where you have like a public load balancer, you probably want to have like these services exposed to the load balancer. And then when you go into /API, you're calling the service A. If you're going to /webhooks, you're going to service B. This is one option, right? This is one option. But you can also have another option, right? Another option could also be, you can also have another option where the public load balancer is talking to those 2 services, right? But those 2 services needs to communicate with other services inside of ECS, right? And some people, it just depends on what you want to use. Some people use a load balancer in that case. So they'll have something like an internal load balancer. If you remember that the things if you remember, you can have actually an internal load balancer, right? So as much as you can have a public, you can have internal. Internal cannot be reached from the outside, right? You can't reach it from the outside. But internally, other services can actually use it to communicate with themselves. That's an option. It's more or less like now, the service discovery is in the hands of the internal, it is in the hands of the load balancer. Because why? When you set up a service, they will register the IPs with the load balancer. And then you have rules that says if you are going to service A, maybe you are doing /, service, let's say /service C. This is going to take you here, right? /service C, right? Service C, okay? And the same thing also here, more or less like if you are going to /service D, you can also find your way to /service D, okay? Service D, okay? So, but honestly, the problem you're trying to solve here is really multi-service communication where you have like a load balancer, it's internal. There are many reasons you want to do this. Maybe it's an architecture that already exists. You can have like a public load balancer that is, routing traffic to some services directly. And then internally, you have like an internal load balancer that is not available on the internet that you can also use to, route traffic between different services, right? Here, the internal load balancer, we are talking about service discovery. So the internal load balancer here is doing the service discovery because the service would register itself with the load balancer, put all the healthy, if you remember, load balancers can help you do health check. So they can actually check when the instance is healthy. If it's not healthy, they can remove it from the pool, right? So what it means is that all they need to know is know the load balancer's endpoint, and then behind the scene, depending on the path that they are going to, they can actually reach any of the services, right? That's one option. Good. What is the other options we have? We can also use service discovery. So we can use service discovery. With Cloud Map. So we do service discovery. Okay, discovery. I'm just going to do this. Okay, so we can use service discovery and Cloud Map. It's also another solution we can use. The whole idea is that that's going to use Route 53. So behind the scene, what happens is that you have a load balancer. It calls one service, but internally, this service actually has service discovery in the form of Cloud Map, using Cloud Map. And this is the example we're going to see. The whole idea is that Cloud Map will be there to more or less like say, oh, you want to see service B, this is how to get to service B. You want to see service C, this is how to get to service C. So another service is there playing the role of service discovery, more or less like telling you how to use to get to a service. But in this case, it's going to be using Route 53 to do that. So more or less like creating a hosted zone, creating a number of records, putting health checks in place, so such that it knows when to remove an unhealthy service from, or like a task in a service that is unhealthy. It knows how to remove it. And if you've also watched some of the times where we were doing more or less like the fundamentals, and we're talking about Route 53, I mentioned that you can actually have health checks tied to Route 53, right? So what it means, and you're going to see practical example, but the point is that you can actually have health checks that are tied to Route 53. And what it means is that it can actually ping the service and know when it's not healthy. And so when an instance is not healthy, you can pull it out. So just know that this is service discovery here. Instead of using a load balancer it's here, you're registering the service with a load balancer. You can also use service discovery in the form of Cloud Map. These are all different services, but they're serving the same purpose. They're serving the same kind of purpose. Your use case will differ depending on what you are trying to do. But in this case, it's using Route 53 to do all that. And we are going to see practical example, okay? But the good thing is that service B can now talk to service C if you want to. Service A can talk to service B, service A can talk to service C, because service discovery is doing the magic. You just need to connect them, right? But there is also a different option, which is called Service Connect. And we're going to see that also. Service Connect is a bit, it still uses Cloud Map. So I still have to give it to Cloud Map because Service Connect will use Cloud Map, right? It will use Cloud Map, just not Route 53, okay? It's not just going to use Route 53. So internally, this is something that is AWS itself. This is something that is built into ECS. So it works. The whole idea is that you can actually have service discovery done for you using Service Connect, right? And we're going to see an example of that. But the thing is that behind the scene, it still uses Cloud Map. It uses Cloud Map. The only difference is that it does not use Route 53. And how does it work? What it does is that behind every task that you create, it creates a sidecar. Okay, it's going to create a sidecar. And if you remember where we're coming from, I think I showed you that a task can actually have multiple containers, right? That's exactly how Service Connect works. So what it does is that your own container will be there. Behind the scene, ECS is going to inject its own container, you understand, for it to be able to do service discovery. And for that reason, once you have that plugged in, each service can talk to themselves. Okay? And behind the scene, Service Connect knows exactly when it does things like retries for you. It can do health checks for you. It can know when a service is okay. I think I'm supposed to be looking at here. So Service Connect can actually do the integration for you. It knows when a service is not healthy. It can actually do retries for you. So there's so many. Behind the scene, all it does is that there is like your container will be here. So let's assume this is a task. So if this is a task, for example, so this is your own task. If this is your task, what it does is that behind the scene, there will be two containers. So the first container, let's do Docker. So there will be your container. So your container will be here. So the way it works is basically, and we're going to see it. It's not a magic. You're going to see it in the implementation. So we'll say your container. So it can be any kind of container. So your container, and then there's going to be a sidecar container, okay, which is the ECS sidecar. Okay, so I'm just going to call it ECS. Sidecar is just something that is like beside the container, and you're going to see that concept when you start doing it. When you also start doing EKS, okay. But again, I think that's also what I've always tried to let you know is that just know how to solve problems. The tooling will change, right? But the idea is the same. So how Service Connect does it is that you have a task. Depending on the task you want to run, Your task will have your own container, and behind the scene, AWS is going to add their own container, and then it uses Cloud Map alongside Service Connect to do service discovery. Remember, we're still trying to talk about how does multiple services connect to themselves once you launch them in ECS. And we've talked about the three options, pretty much the three options. You can use a load balancer to do the service discovery. You can also use what do you call it? You can use service discovery with Cloud Map. In this case, it's going to use Route 53, and then you can also use Service Connect itself, which is kind of like well knit into ECS, how ECS works, where the concept is like your container. ECS gives you a sidecar, and that is really where the magic happens, where it knows which service to talk to, right? You're going to see how we'll set them up. But that is still trying to answer our original problem, right? The original problem we had was here. We had two services. One service, we had another service. We wanted to communicate between the two of them. We took a shortcut, and the shortcut is to have them into one task definition. But in this call, we're going to be breaking them apart. So we're going to be having independent services for both of them, and then connecting them together in an easy and likable way. Very, very easy way. Okay. So that's what we're going to be doing. So what I'm going to do is everything we've created in the past, I'm just going to use Terraform to bring it up. Okay. So that we don't have to go through the stress of provisioning them into the account again. So I already have that set up. I think the only difference is that here, honestly, it's the same. It's the same with the things you've seen before. So I'm just going to do Terraform apply, and then I'm going to show you the things it brings up for me. Okay. I'm also going to tie it back to the diagram. Okay. So we're going to do Terraform apply. This is where it's going to set up the VPC, set up two subnets. If you check the network here, there is like a VPC, two public subnets for those who are asking questions. You have two private subnets. There's a NAT gateway. All that is there. Okay. So we're going to set all that up as part of bringing this up. It's also going to set a database. It's going to set up some secrets for us. So let's give it time. Elastic IP. In this case, not really. Yeah, we will need Elastic IP because we are using a NAT gateway. We are using Elastic IP somewhere. I'm just not talking about it because we are using a NAT gateway. There's an Elastic IP somewhere where we're using. Okay. So that is really. So this is going to take some time. Let's bring up the infra. Okay. So let's bring up the infra. Let's bring up the infra. It's going to take some time. All right, so after giving it some time, the Terraform apply is done. And we basically, at this point, what we have done is that we've set up the things we had in the last call. So let me just zoom this in. So what we did now is that what I broke, we did create two services. So we now have two services. So there's one service, and then there's also another service, which is the webhook service here. Remember in the last call, we had it, two of them were using one service, but two containers in the same task. So in this, the one that I just provisioned with Terraform, what we are now doing is that we've broken it apart. So one service will have its own task. The Go service will have its own task. The webhook service is going to have its own task definition. Okay, that's the difference. That's the new thing we've added. So let's see what that translates to in the console. You can see there are two services. There's the Go service, there's the webhook service. If you go to task definition, there will be two. That's exactly what I was trying to say, that we've broken them apart. So there's one for the Go service, there's one for the webhook service. If you check the webhook service, I think one thing you'll see, if you try to create a new revision, the most important thing you'll see is that it's trying to go to ECR to fetch an image, right? It's trying to go to ECR to fetch an image. We saw that in the last call, how we built an image, we pushed it to ECR. But if I go back to ECR now, I think we don't have that image. And if you go to ECR, for example, the registry is here, but there's no image. And then when we go back to the task definition, so more or less like we go here and we see, let's go to the cluster, we go to services, we go to the webhook service, you will see that it's complaining. I think it's not running currently. And the reason is very simple. If you check here, it is saying that it's failing. So it's actually trying to get the image from ECR, but it cannot. So these are steps also you should get used to, troubleshooting containers, why they're not starting up. So if you ever go somewhere, maybe they're asking you, why is it, what could be the problem when something says task failed to start? This could be a solution, right? There are many things. It could be maybe the image has not been uploaded. In this case, it's saying that the ECR image is not found. Okay, so the next thing we want to do is let's upload that image. So what we're going to do is we'll just go back to our playbook. If you remember that the last time, I had a small set of ECR text here that we had, right? If you remember, the webhooks had a folder here. That's where the service is. it has a requirement.py file that we added. It had an app.py file. It had Docker file, which is really what containerizes it and pushes, that can allow us to push it to ECR. So what we are just going to be doing here, I think the first thing we want to do is, I think if you watch the last video also, we've done this in the past. I'm just going to replay it again. So what I want to do is I'm just going to export my account ID so that I can, no, that's not what I want to copy. So I'm just going to do exports. I'm doing it in the wrong place. I'm just going to do exports. Account ID is equal to this account ID that I have here is mine. So I'm just going to paste it here. Ugh, I didn't want all that, but let's go. So I'm just going to paste my account ID. It's here. The next thing I want to do is basically log into ECR. You have to log in. So I'll log in, get login password. The command is there. You will always run that command every time. So the next thing I also want to do is build. Remember, we built the image for our ECR. So I'm just going to build it. Here I'm targeting Linux AMD, okay, 64. You can also target ARM if you want to. Once I do that, also if you were in the last class or you watched the last video, we did all these steps, okay? I'm just replaying it again so that you know we are not doing magic. So here we are building the image. It has finished building. Now we just want to tag it. So we'll tag the image. We'll tag it. Once we've done tagging, let's push it to ECR, okay? So we'll push it to ECR. Webhooks receiver does not exist. I think because I changed the name is now Ghost Webhooks receiver. So I'm just going to change the name. But whatever name you name it, just make sure you're following it correctly. So I'm going to push again. Push. What is it saying? This does not refer to. Does not refer to what now? Let's see. I think, yeah, this is the repo. Tag does not exist. Okay, yes, and I think I know the problem. That's because we did tag before. We did the wrong tag. We tagged with the wrong repo, so we just have to correct that. So I'm just going to go back here and tag it again. Please, these steps, we've done it last time correctly, and it's also in the blog if you want to see the exact step, okay? So it's not, we're not doing, I don't want to do this behind the scene. I just want to do it as part of the call. But we'll tag it again, and then we'll push it to the right repo, okay? So we'll push it to a repo. Now it's going to push. So what it means is at this point, the service is ready. So we now have an image, right? So the image is now in ECR. We didn't have before, but it's now in ECR. So the point is, at this point, ECS, once, because it's a container orchestration service, once you have a container, whether it's in ECR, whether it's in Docker Hub, wherever it is, ECS can run that service for you, okay? So let's go back to ECS. What we did, you can see the error. This is the error it's saying, cannot pull. This is the reason it cannot find the image. But now there's a latest image. So we can actually, if we give it some time, it's going to correct itself. But we can also just go to ECS and then update the service and force a new deployment, okay? We can do force a new deployment and then update it. So once we force a new deployment, let's give it time. It should bring up a new task. This time, it should be able to find the container, okay? If I refresh this page, you see it's provisioning. So there's now a new task that is trying to come up, okay? So it's provisioning a new task. So let's give it some time for that task to come up. If you remember, this is still similar to what we've done in the past, right? We've had two services that we worked with. The only difference there was that we had the two tasks, the two services, the two containers in one task. But now we've gone ahead to break them apart. That's it. And if you followed me from the beginning, you saw that it's very easy. You just create a task definition. And from the task definition, it will generate a task. A task is what powers a service. And in this case, we have two task definitions, one for the Ghost service, one for the webhooks. If you go back to cluster, we have two services now, one for the Ghost, one for the webhook. So just think about, we just broke them apart. And then each service is going to bring up its own task using its own task definition. So in this case, you see multiple tasks, right? So in this case, this is the webhook task running. There's the Ghost task also running. It looks like it's running, right? So what we can do is that let's pick a service. So for example, let's just pick, we know definitely the Ghost one is running because that's exactly what is showing here, right? So when we went, this is it, it's working fine. So we know this one is working fine. We just need to now check the webhooks. The webhooks will go here, we'll click on it in the service. We'll click on the task. We'll check the logs and see what's happening. Yeah, it has started the service. So the service is running. We saw this the last time. This is running. It's running fine. It has started the service. Everything is fine. After a while, I think you can see 0 pending, 1 is running. So our two services are working. They're working exactly as expected. But I'm going to be showing you some tricks on this call, which is to target the things we want to do. Okay. So we now have two services, and we want those two services to communicate with themselves, right? We want them to communicate with themselves. So the first thing I'm going to be showing you, first of all, is that I want to be able to, first of all, go into one of the service and see how do I connect with the second one. Remember, these two services are kind of isolated now. And the way the Terraform script that I brought up, it actually have multiple security groups. So the first thing you need to see is that if I go to security groups, you know, each task, because it has its own task definition, it has its own service. In this case, they can actually use multiple security groups such that you can decide which service can talk to which service. You can have that level of isolation, right? But if I go to security groups, you see I have a number of them. One thing you notice is that the webhooks has its own security group. And then the Ghost itself has its own security group. If you check the Ghost security group, you see that the inbound rule only allows the load balancer. That's it. And that's exactly from the diagram. You can see that only Ghost can be reached from the load balancer, right? But we said we want to be able to now have the Ghost service talk to another service inside of ECS, right? And that's what we're trying to do. We're trying to do service discovery in this point, because we want, if you have to talk to another service, you have to be able to find the service and discover it. So if we go back here, let's go back to the other security group. So we'll go back, we'll check the webhook security group. Right now, it does not have any inbound rule. We will fix that, okay? We'll fix that. So what we really want to do is, let's start from there. So I'll go and edit the inbound rule. I'll add a rule, and I'll say I want all traffic, okay? In this case, you can also limit it if you want to, but in my own case, I think I'm actually okay for the Ghost EC2, the Ghost security group to be able to access it. So you can see Ghost ECS security group. I'll say allow Ghost to connect, okay? To connect, cool. I'll save the rules, it's there. So now what it means is that on the networking layer, I've been able to establish connection from the Ghost service to the other service, right? Security group wise. There's also something I want to show you. So we'll go back to the cluster. What I want to be able to do is I want to go to the services. And in this Ghost service, I want to be able to exec into the container of that service and be able to see if I can connect to the webhooks, right? If you remember in the past case, we can do it from the UI, but I actually want to do it now from the containers themselves. So what I'm going to do is I'll click on Ghost. I will go into, what do you call it? I'll try to update the service. What I would try to do is there is a place for troubleshooting, right? Troubleshooting configuration. And I can actually turn on ECS Exec. The whole idea is that you can actually exec into your container, okay? So I can turn it on for Ghost in this case and try to update it. I know it's going to fail, and it's intentional, okay? It's intentional. It's going to fail. And the reason it's saying is that the role ARN is required. There is actually a task role ARN that is required. If you remember, when we create a task, there's usually the task role, and there's also the task execution role. I've told you what the two of them are meant for. In this case, it's saying that the task role ARN is required, because if you check that task definition, it doesn't have. So what we are going to do is I'll click on this link, and it's saying that you just need a task that has this permission, okay? So what we are going to do is let's create that role. So what we are going to do is we'll go to IAM, we'll go to IAM roles, and we'll look for the role that has the ECS. So there's ECS task exec, and there's also ECS task, okay? There's ECS task. But again, what I'm going to even do, I'm going to delete this so that we create it from scratch, okay? So I'm going to delete this entirely. I created this before, so but I want to create it fresh on this call. So what I'm going to do is I'm going to open this in another browser, and then I'll say I'm creating a new role. In this new role, I will say the custom trust policy is actually going to be the same custom trust policy that we're going to be using. So an ECS task is the one that is going to assume it. So I'm just going to copy all this, the same one that we're using. I'm going to paste it here, okay? Then I'm going to do next. Now I don't want to give it any permission for now. I'm going to do next. And then I'm going to call it ECS task, okay? So I'm just going to call it ECS task. I think if you see this one is Ghost ECS. So instead of task execution, I'm just going to call it Ghost ECS task. So this task role is what the container itself needs. There is also task execution role, which is something that is operating at the service layer, right? So I'll say ECS task role, okay? So task role is what I'll call it, role. And then I'm going to do next, I'll create the role. And then I'll look for that role that we just created. So is this one. The permission I want to give it, so I'm going to go to add permission. You know, we know how to do this. We're going to create an inline policy and say we'll just paste the JSON. And the JSON is really what I got from, so what we saw from AWS just now, so which is this one. So I'm just going to copy everything here. I'm just going to paste it here on this policy. So paste it. And then I'm going to do next. I'm going to save it as allow ECS Exec. Okay, cool. So what this just means is that you are allowing you can exec into the container. You're going to see a practical example. So we now have this. What we will now do is that we'll go back to the task, the service in this case, I think it's the Ghost service. We'll go to the task definition for Ghost. Remember, the task definition is really where all the definitions are for the task. So because we now want to use a role, we have to effect that from the task definition. So we'll go to the task definition, we'll go to the one for Ghost, we will create a new revision, right? And in this revision, what we are really doing is to pick a task role. So in the task role, we're just going to choose the one we created, right? So here, which is the Ghost ECS task, there's an execution role. That's not the one we're working with. We're working with the ECS task role. So we are going to save it. That is going to create a new revision, right? So we now have a new revision, revision 4. What we now need to do is that when we are updating the service, before it was giving us error, which is here when we turned on, we now need to update it to that service that we just created, the task definition, the task definition revision that we created. So we'll check this one, we'll refresh. There's the fourth one. We'll choose it, and then for that reason, we can now turn on this and see if it's going to work. We'll say update. This time it worked. You can see it has updated, right? So let's give it some time. And what the difference you will see is that when you go to task, for example, there is a task here running. If I click on it, there is no place for me to connect. You can see this connect is hidden, right? So what we're trying to do here is that we're trying to be able to connect into the container, right? And that's what we are enabling. That's what we just enabled. So we would wait for a new task to be brought up that has that integration that we just did, and then we can connect to the container. Okay, so we'll go here and see the tasks that are coming up. I think this one is running. This was 16 minutes ago. We need a new one. Yeah, you can see there's a 14 seconds ago that is coming up. So that's the one we should wait for. Okay, this one is the one we should wait for. And then we can continue testing from there. Remember, our original task is still service-to-service communication, right? We want two services to be able to connect to themselves. Okay, so let's give it time to come up, and then we can continue from there. Let's see. Let's give it some time to come up, and then we should be able to connect from there. Cool. So let's see, it's activating. Let's see, if you click on the task, we want to see connect. Right now it's not showing yet, but we want to see connect here once we're ready. I think we can give it some time. For the other Ghost task, I think that one is working fine, right? We can already see it from the logs. If you go to cluster, you go to the service, you'll see that its own task is running fine. If you check the logs, it's all good, it's clean. So I think right now it's just waiting for, I think in the last 15 minutes, we can take this to the last 1 hour, apply, you see the logs, right? So clean service, the service itself is working. It's just waiting for a connection for us to see what is going on. So we can actually go to the old service, which is the one we're actually working with, the Ghost one, and see if it's running. One is unhealthy, I'm not sure why, but let's see the task. This is still activating, this task 4. This is the one we are interested in. So click on it. We'll refresh. It's still not up here, but can you see the difference? If you can see the difference, one thing you notice is that there's now a connect button, right? So what I can do is I can click that connect button, right? And it tells me the command it wants to run. So it's saying it wants to execute. I mean, this is SSM, if you understand. It's basically trying to do ECS execute command and all that. But the point is that it's trying to use this shell. I'm going to update it to use a different shell. So I'm just going to use the bash shell, okay? And then I'm going to run. I'll click on run. At this point, I'm basically just trying to go into the container. And if it succeeds, I'm happy because now I'm in the container. So if I actually wanted to do something inside the container, I can do it. So I'm inside the container now, right? So I'm inside the container. So what I can do is basically see, because I'm now inside of the container. The question is, what can I do inside this container? Remember, in the past, we had to go to the Ghost UI to test connectivity, but you can actually test it at the container level. And that's what we've done because we've exec into the container, and then we can do a number of things. So I have a command here, and I'm going to show you what I'm doing. I'm just trying to do apt. So I'm going to paste this command. I'm doing apt update, so I'm updating. And then I'm installing curl. I'm doing IP utils so that I can have some things to run. I'm also installing DNS utils, and then I'm installing JQ, okay? these are just bundle of things that I'm installing just to be able to run the kind of commands that I'm running. Okay, so what I'm going to do, I'm just going to do this. So it's going to update the OS, and then it's going to install the things that I've instructed it to install, and then we'll continue from there. Okay. So remember, we're inside of the Ghost task now, right? But the whole idea, we're still doing service. We still want to prove service to service connection, interconnection. Right now, we've gone into the container, and then we'll try and see what can we do from this container. So it's finished. So the thing is, if I do ping google.com, what will happen? So it means I can go to the internet, right? At this point, inside of the container, I basically can go to the internet. So what I can do is I can actually do Control-C, and what I can do is basically go back to so I'm just going to leave this open on one side, and then I'm going to go to the other task on the other side. So the Webhooks task. So I'm going to go here. This will always follow me around, which is a good feature. It's always going to follow me around. You can see everywhere I'm going to is following me. Okay, so I'm just going to zoom in a bit, go into the cluster, go into the task, go into the Webhook task. So I'm here. So what I'm going to do is look at the task, check the one that is running. I think there is one here that I can pick. My screen, real estate, is what I'm fighting for now, but let me see. So there's a task here. Let me actually take this down. Okay, so there's a task here. I'm going to click inside the task and find out the IP address of that task, right? So we would see that it has a private IP, which is this one, right? So what can we do at this point? Can we ping the IP and see? We said we actually allowed all traffic on the machine, right? So we can actually ping. We can ping that IP. So from the Ghost service, we can actually ping the Webhooks task in this case. So we can actually do that. We can also can we test call? Like, can we try to reach the service? Remember, we know the port the service is working on is 8,000, I think. Yeah, it's working actually. Just to make that clean, we can do JQ here. So you can see actually that we can connect to the service. It's not that there's no problem. So in the past, we had to go to the Ghost web, like more or less like the UI to connect to the service to show that. But again, we are just doing it here from the container. So at this point, you can see that I can actually connect to the task using the IP address. But there's a problem. You don't want to. This IP address can be down anytime. Like I can turn the replica to 0. So this IP address is not reliable. Rather, you want a reliable way for you to talk from one service to the other, right? Using a clean name, a name that is friendly, a name that you can approach, or a very friendly name that you can use, something like webhooks.dev, right? To connect to the other service. So that would always, you're not really you don't care so much about the IP address that is servicing it, because you know that if you discover it, regardless of the IPs that are behind it, you can always, respond to the traffic, okay? But we know, at least from a networking perspective, one task can talk to the other task, the other service, basically. But now we are talking to the task directly. We actually want to talk from service to service. So that's what we need to solve. What are the options? If you go back to my diagram, I showed you all the options that we have, right? We said you can use a load balancer to route the traffic from the services, right? In this case, we have webhook service. We can actually create a load balancer and put that service there and make it discoverable. And then instead of me calling the IP address directly, I'm going to call a load balancer DNS and reach the service. But I don't want to go that route. So what I'm going to be showing you first is let's use Cloud Map. So we're going to use service discovery with Cloud Map, right? So what we'll do is that we'll go back to that task. In this case, we'll go back to the task itself that we want to be seen. In this case, which is the webhook task. So what we're going to do is that we'll go to the task. We'll actually go to the service. So we'll go to the service. I will need to bring this down a bit. So we are actually going to the webhook service, right? But before that, let's go to Cloud Map. So we'll go to Cloud Map because that's the service we're going to be using. So we'll do Cloud Map. And then we'll go to Cloud Map. The first thing we want to do is basically, we want to create a namespace. I have a namespace here, but I'm going to delete it, okay? So that we start from scratch. Okay, so I'm going to create a namespace. This will take some moments to delete, but let's give it some time. In fact, let's create our own namespace here. So I'm going to call it TikTok, okay? That's it, because I want to do webhooks.tiktok and then see my service, right? So the thing is that when I do this, the next thing I want to do is I'll say my TikTok namespace. And this is my own practical example, but remember that in an ideal world, you want to have namespaces. Maybe you want dev, you want QA, you want prod, and then you can put services in those namespaces, however you want to organize it. But Cloud Map gives you that ability such that you can actually have a namespace and put services behind that namespace and then have them configured in a way that is just very easy for you to reach out to those services. So there are many options here. There's the API call, there's API call DNS queries. In this case, I'm going to use DNS queries and API calls inside of a VPC. So I'm going to use this option, and then I'm going to choose the VPC. The VPC here is the VPC for the infra that we're building. So we're going to use Ghost VPC, and then TTL 15 seconds in this case. TTL is just basically time to leave, right? So because this is using Route 53 behind the scene, it means that it's still going to be controlled by TTL. Okay. So what we will do, we'll do TikTok, we'll do again. TikTok is just my example. Okay. Ideally, you want to have like groupings. Okay. So these resources, these services are inside of the dev namespace. These resources are in the QA namespace. These resources are in the prod namespace. Just however you want to organize things. But in this case, I'm going to be creating a TikTok namespace, and then what I'm going to do, I'll create a namespace. The dev namespace is already gone. This is going to take some time to create. Okay. So let's give it some time. But one thing you will notice if I go to Route 53, because it's going to use Route 53 as an option, one thing you know is that I have one hosted zone now, but once I include that, there will be a hosted zone. So if you know Route 53, just know that behind the scene, that's what Cloud Map uses, especially if you're using the service discovery option, not the service connect, okay? It's still going to create like a hosted zone, and then in there will now be records that does its magic. And I think if you join me on some of my Route 53 calls, we looked at how Route 53 works, how you can create, you can create DNS, more or less like you can route to services using health checks and many of the other beautiful things that you can do, right? So let's refresh and see. You can see a hosted zone has been created for us, right? So the TikTok hosted zone. If you notice, it's a private hosted zone, right? Meaning it's private. And I think I've shared also what the meaning of public hosted zone, private hosted zone, right? But this is a private hosted zone, meaning within our private instances. Good. So that namespace has been created. Really, that's the most important thing you need to create. Again, when we go into Cloud Map, this is not a Cloud Map class. There's so many things you can do with Cloud Map. I probably will be teaching them at some point. But the thing is that you can come here and create services your own by yourself, right? So you can actually create services, create a map of your services on AWS and give them friendly names that people can reach to, like you, that people can connect to them with, right? And there are many ways to go about it. But in this case, we are using ECS, and then we are mapping to Cloud Map and then mapping to Route 53. Okay, so we're not going to be creating our service manually because ECS gives us that connection. ECS can actually do it for us behind the scene. But ideally, it starts from creating a service. You create a service, for example, give it a service, had health checks, because again, you want to know when the service health point is healthy and all that. So what we're going to be doing is we'll go back to ECS. So remember the service here we want to talk to in a nice way, because the external service is already being talked to in a nice way. I mean, there's like a friendly DNS name we're using to see the service. The other service is the problem because we are still reaching it via IP address, but we want to go with a service, right? Instead of using like an IP address, we want to use a friendly DNS name. So what we're going to do is we'll go to cluster, and we'll go to the webhook service. In this case, that's really what we want to work with. We'll update the service. The first integration we'll be doing here is to do service discovery, right? That's the one I said as the first one we're going to do. So what we're going to do is here, we want to use service discovery. We'll select an existing namespace. We just created one in Cloud Map. So if you don't have, create one. But here we have an existing namespace. We're going to choose it. It's TikTok, right? And then it's saying create a new service. We want to create a new service actually, right? Because this is the first time we're doing this. So we need to create a service, and we'll call it Webhooks, okay? And then we'll say my Webhook service, okay? So Webhooks service. Good. And then we're also enabling task health propagation. The whole idea is that your ECS can propagate the task, basically, communicate that same health of the ECS service back to Route 53, right? So that it knows when to remove unhealthy endpoints. And I'll show you exactly what that translates to. It creates a record. We want an A record or what kind of record, but you can do all that. So we're going to update this service. So the service has been updated. Now that the service has been updated, one thing you will notice is that I'm sure it's going to try to bring up a new task, right? For the one that we just added. Remember, this is the webhook service, not the original, not the Ghost service itself. This is the webhook service. And remember, in the past, we were still doing, we were trying to connect to the service using an IP address, right? Because there's no service endpoints that we can use at this point. There's no service endpoint that we've discovered. We are just trying to create that. Right now, we're still talking to the service using an IP address, but that's not sustainable. IP addresses can change. New tasks can come up. Many things can go wrong, right? So we want to be able to reach through the service. The service behind the scene knows which tasks are healthy that can handle the traffic, okay? So we have that running. We're just going to now go back and check, check So let's go. So we've created the integration from ECS to service discovery. What we now need to do is let's actually start from Cloud Map. So we'll go to Cloud Map first and see what was created for us. Remember, I told you you can create those things manually if you want to yourself, right? So let's go under the namespace called TikTok. Let's refresh. There's now a service that was created for us. ECS created that for us, right? So he created this webhook service, right? And he said it's healthy, right? So the health, he said it's healthy. So it probably has done health check against the service. It knows exactly, what's going on. What's the next thing we need to do? Let's check hosted zone. We had one hosted zone, 2 records before when we created it. Let's refresh this. You now see there's 3 records. What's the 3rd record? When we click on TikTok, you see there's now a webhooks.tiktok DNS, like a record name, right? That we can now reach. And behind the scene, it's the IP address 10.10.20.253. And if you check behind the scene, what were we doing before? If you remember what we were doing, for those of you who were here, in that case, I think it's basically connecting to let's see which of the services this. So let's go to task. Let's go to task, webhooks tasks. Let's go to the task we were running. My screen I thought I had a big screen, but now. So if you remember, we had one that we tested directly, right? But a new one has come up, and that's the one that was registered. I think that's the one that was registered to Route 53. But let's actually check it. Is this one? What's the IP address? Private IP 10.10.20.253. So that is exact. So it's not magic. It is Cloud Map that does the integration with ECS. Behind the scene, there is a record in Route 53 that is created, and then you can connect using that to the service, right? But if you see this is 10.10.20.253, it matches exactly with what we have in Route 53. So 10.10.20.253. Okay. What are we now going to do? We now have a new name to connect to. So we don't have to be using the IP address again. So we can actually, but again, let's actually click on this record and see what we do, what we have. One thing you need to notice is that there's a health check that has been created for us. And this health check actually manages when a particular task is healthy or not. It knows when to remove it, when to add it, right? And it's also not managed in this account. So it's AWS managed in this case. So what we now need to do is, let's go back to what we were doing before. So in the task, if you remember here, we were doing, before we're having to call an IP address. Let's even see what is going to happen. Let's try the IP address again and see what we get. So let's see. It hasn't loaded or what? Let me see. I think I'm in this session. I think this session is frozen. It's not letting me type. But let's create a new one. It's not a problem. We can always create a new one. So let's go back. Oh, because maybe that container restarted. Okay. So let's create a new session again. Okay. Against a ghost task. So we're going to go to ghost. We're going to go to the service itself. So we're going to go to clusters. We're going to service, the ghost service. And then we'll look at the, the tasks that are running. So there's this one that is running. The first one has been stopped. And then, we actually created an integration to connect. So we're going to connect. But sadly, I think we may have lost the command that we installed before, because if this is a new container, we've lost that. So maybe this is one of those things you bake into like an AMI or something. It depends. Although this is Fargate, but the whole idea is that maybe you want a container that has some of these instructions, right, that you can run, especially in your Docker file. But in this case, I suspect that if I do curl, it's not going to work again, because this is a new container kind of like that we're entering. So if I do curl, it's going to tell me, I don't think it's going to be here, because we've lost that first container we're working with. So sorry, we have to run the command again. If you remember, I have the command handy here. I'm just installing those things. So do update, install. But this is also where Docker file comes in, because in your Docker file, you can actually put the things you will need for that container. If you know you need to be using curl, put it as part of the Docker file. If you know you need to be using some DNS commands, put it as part of the Docker file. So these are some of the benefits of like putting the things you need in the Docker file and then packaging them, right? So we have all those things back. The question is, before we were reaching the service using an IP address, we shouldn't do that again, because we now have a DNS. So what I can do is now to do curl, and then I'm just going to do HTTP and do webhooks. We'll do webhooks and do TikTok, and then do port 80, 8000, right? Because that's where the service is, and see what are we going to get. Are we lucky? It's working. It's working. It's working. So now we can now reach the service. Instead of reaching the service directly from an IP address, we are reaching it using a friendly name, right? That we can actually reach. So in this case, we're doing HTTPS webhooks.tiktok/it port 8000, that's where the service is running on, right? So we can actually connect to that service. If we take that further, when we do dig, we just do short in this case, and we do this webhooks.tiktok. What do you think we're going to get? This. It gives us an IP address, 10.10.20.253, right? One IP address. But what happens if we scale that task up? Let's scale the task up. So let's more or less like create multiple tasks for that service. So now Webhooks is scaling, and we now have multiple IP address for that webhook service. So what we can do is we'll go to task, we'll go to the service. In this case, we'll go to the webhook service, this one. And then what we are going to do is we are going to scale that task. So we're going to go here, and we will say, we'll update the service. This is where you can choose replica, right? So desired task, we have it set as 1. Here, I'm going to set the desired task to 2, right? So meaning I need 2 containers. So it's as easy as that. I'm not provisioning the machine, but now I can say I want 2 tasks to run. So what I'm going to do is I'm going to update. So after a while, it's going to bring up more tasks, right? A task is really a container in this case. So it's going to bring up more tasks and more container. Cool. So with that coming up, let's see what we get. So if at some point we dig, now we're still seeing just one IP address, right? Behind the scene, just one IP address can respond to this traffic. But if that task becomes healthy, what do you think is going to happen? We will have multiple. Let's do this. There is still one. Remember, there's a health check that it needs to pass. If the health check is good, it is registered as part of the DNS, right? So now it's still seeing just one IP address. So let's give it some time. Let's give it some time. Let's go back to the service and see if it's launching. So we'll see task for webhooks. You see there's one activating. So there was one before that is running, but now there's another one that is activating. So this one. So this is the one we're waiting for. It cannot be registered as part of the DNS if it's not healthy, right? And you know if the task is coming up, there's a number of things that will need to happen. The service will need to be validated. The service will need to be confirmed that it's working as expected, and it is registered as part of the DNS. In this case, Cloud Map and using Route 53. Okay, so let's refresh. It shouldn't take long. It's now running. Let's go back and check and do this. What do we get? Now we now have 2 IP addresses, right? So it means that when you send requests now to that URL, any of these 2 tasks can handle the request. So I can actually go back and say, I can do something like what I was doing before. It's still going to work. But behind the scene now, any of those traffic can receive the request, right? So when we go back to what we had before, so if you remember here, we did something like blah, blah, blah. And if you remember, we had my awesome sites. I'm just going to do this, sites, whatever. Just call it and do Brainyl. Just do brain test at brainyl.cloud. I'm just going to put a password here. Just so you know, if you can test it internally like that, you should also be able to test it you should also be tested with the service. So if you remember, if you watched that video before, how did we do it in the past? We did it manually, right? So we had to go through this route. But now I know that service is working. So I can actually go integrations, for example. This is real application of what you have already done on the networking side. Maybe this is what the application is seeing, what the application is using. But behind the scene, as a DevOps engineer, you've created that infrastructure already, right? We have it set up. So what I'm going to do here is I'm going to go to custom. And here I'm going to add a custom integration. I'll say webhooks integration. This is basic stuff. We've done this before. And then I'm going to add a webhook. So what do you think I'm going to do? I'm going to do member added, for example, this one. And I'll say when a new member is added. And then the URL, what do you think I'm going to paste here? Instead of pasting the local host that we used before, this is where I'm going to use my new service. Because now I know there is a service, discoverable using Cloud Map that I can connect to. So what I'm going to be using is go here and copy that URL. So here, HTTP webhooks /8000. And I'm going to go back to where I was before, paste it here. But remember, if you go back to code, if you remember the webhooks itself is opened inside of, it is responding at a particular endpoint, which is /webhook, okay? So we have to take that /webhook and paste it here, okay? And then this is optional, but I can do my simple secret, right? And then do add. So when I do add and I save, that's, it's the integration is there. I'll just close this. What do you think is going to happen? So let's go back to what we're doing before. We usually tail the webhooks container to see if it receives a request. So let's go back and see what that will look like. So what we can now do is we can go to CloudWatch. So you see, we are touching a lot of services here, right? That's it. So as time goes on, as you play with all these services, you begin to see what a typical DevOps does, right? All this, you're working with all these services here and there. So we'll go to CloudWatch. what we're going to do, we will tail the webhook service. So we'll tail the logs from the webhooks. So we'll go here, we'll do logs, we'll do logs management, and then we'll look for the webhooks logs, okay? So we'll do this one. And then what we'll do is that we'll just view in log insight. And then what we can do here is just query for the last 30 minutes, okay? So we'll do run query and then see what we get. So in the last 30 minutes, there's really nothing. There's nothing. So let's test our integration. What we can now do is let's try to create a member. So we'll create a member, right? So we'll create a member. We'll call it new member, right? Member. This member, we'll just give it a mail, just a member at gmail.com. So this is what the application is seeing, but behind the scene, there's a network, there's security, there's many things, right? So a lot of people operate on this layer. That's all they care about. The application is working, but behind the scene, a lot is happening, which is what we have done. We've done the work. We've created the container, we've packaged this, we've pushed it to ECR, we've created the networking, right? But to the end user, all they are seeing is things are working. So when they create something here, but behind the scene, you have to own that, right? Which is what we own as part of our job, okay? So here I'm just going to say blah, blah, blah. It doesn't have to be anything, and then I'm going to save, right? So at this point, I've saved a new member. So ideally, once I've created a new member like this, you should be able to go to that endpoint, right? And see and talk to the service, right? So what we can do is we can go here and we can refresh. So we can refresh this page. Where is that refresh button again? So run query and see. Nothing yet. I don't know if it's a good time or maybe it's a wait game, but we can wait. While we are doing this, we can also check the other service, which is you can actually you can search multiple logs. So in this case, I can actually do the ghost one. So I don't know which of them is this now. CloudWatch, or let me just refresh this. Maybe while we were waiting, maybe it's here already. It's not there. But let's check the other one. So let's do no, I think I should be doing this. Let's check the other, let's see if it's having issues connecting. But at this point, honestly, we've tested it from inside the container. So I don't think it should be a problem. But let's see if there is a ghost log. I don't know if it's which of them now. 2 weeks ago, let me see if this one has any new. So this is 14th, so nothing. So probably it's the last one, the first one here. Is it this one? Yeah, this one has events for today. So let's actually view in CloudWatch and let's trigger for the last 30 minutes to see if there was a call to send something to the webhooks. So there's an admin post here. Let's see. Let's see. Authorization failed. That's not I think it's 31, 35, 30. Yeah. So it's actually in descending order. Let me just patiently search for that and see if it's going there. Sometimes it takes time, but let's also refresh here. Maybe it has come now. Let's refresh. Still nothing. So let's go back here and see where something looks like filter. I hope you know if you're using CloudWatch, there's so many things you can do. You can do some filter expression, but let me just say filter, where the message is like webhooks, right? So we're just going to do webhooks. Let's see if we find anything. Okay, so let's try this one and run the query and see what we get. Yeah, so you can see it says this. So triggering webhook for member added with URL. You know this, but it didn't really complain. So this happened 22 some minutes ago, so it shouldn't actually take long. So let's actually filter, and then let me just apply this and then remove the filter actually. So we should be able to find it. I think maybe I can close this. We don't have to go back here again. So let's actually do webhooks and search. So yeah, it went actually. So you see, it didn't complain. So that means it actually worked. So it actually worked because there's no error. It went fine. So let's actually check the logs. Maybe we're not checking the right logs. Is this the wrong logs or what? In the last 30 minutes, there's still nothing. Let's go to logs management. Let's look for webhooks. I suspect maybe there is a different. Oh, we were checking the wrong webhooks. So I'm going to let this go. But this is the one we should be checking. This is the one that has 15, there were events today. So let's actually view in log insights. Let me close this. I don't need this again. So let's just do it in the last 10 minutes, okay? So we'll do last 10 minutes, we'll apply, and then we'll run the query, okay? So let's see. Yeah, you can see, yeah, the request actually came. I think we're looking at the wrong webhooks, but you can see there was a request, right? HTTP is here. This was when the service started running, right? And this is when the request came in, right? So if you check, it is that member that was, what do you call it? So member at gmail.com. That's the new member that I created. What have we done? Before, we had one task, 2 containers, and we were using IP addresses basically we were using localhost because we bundled both of them in one task, and we're using localhost to connect, right? But now, what we have done is we've used service discovery and Cloud Map. We use service discovery with Cloud Map and then Route 53 to pretty much give it a friendly name, a friendly DNS name to reach out to, right? But we know behind the scene that DNS name is basically backed by a couple of tasks, right? So, and the client doesn't need to know. All it needs to know is just that friendly URL that you have given it, right? But behind the scene, it is powered by a number of tasks that can handle the request. Good. So let's go back and see what that looks like in our diagram. Okay, so I don't think we'll be able to use Service Connect today, right? We will stop today on Service Discovery with Cloud Map. The next time we're going to extend it with Service Connect. But again, I'm going to show you the concept. But the whole idea is that if you look at where we're coming from, the UI is really what the user sees. But behind the scene, we are building the architecture, right? That powers the application. And I said that we started from here, we built this, and we said a quick way for 2 services to talk to themselves was just to use localhost. And we said, one task, we have 2 containers. And we said, but that is not good because now we sometimes want the webhooks to be able to scale independently of the Ghost instance. So it means we need to break them apart. So we went through the second architecture, the more or less like the second iteration of the solution, and we said, create a different service completely. So now we have a webhook service that has its own task. You remember there was a time we actually increased the number of tasks to 2. So it has its own task. It has its own task definition. It is pulling image from ECR. And now what we also did was now to create a piping such that this guy is connecting to here using what URL did we use? Let's actually copy that URL so that you know that that's exactly what we achieved here. So we did integrations. We actually used that URL, which is custom. It is connecting using this. So it is this one. It's actually added to the diagram because we made progress. So what we did is that we created a new integration, right? Now, what it means is that these 2 services can actually connect, but instead of connecting using a name that they don't know, they're now using a name that they know. I think this is not, let me go back. Okay, let me just use a text. So let me paste this here and then be able to zoom it. So just zoom it in a bit. Oh, I think that one went a bit further. But what the whole idea is that now, when the Ghost service itself is talking to the other service, instead of having to do is calling the IP address like we had in this very faulty, like in this implementation, we now swapped it completely to have 2 services that are independent from themselves. But the good thing is that we can scale this, right? We can have multiple tasks scaling for this one. We can have multiple tasks, and then all you just need to know is really this URL. It's never going to change. But behind the scene, there's a lot that is happening, right? A service will come up, it will bring up its own task. It is backed by a task definition. It goes to ECR, it pulls an image. And like you saw in the command line, like where we were here, you can see that if we connect to the container again, if it's still there, if we're lucky, it's still there. If you go back and you dig for it, it's still going to show you 2 IP addresses, right? It's going to show you 2 IP addresses. So all we need to know is this webhooks or TikTok, but behind the scene, there's a number of tasks, all right? I can continue to increase this. I can put multiple tasks, 5 tasks, 10 tasks, and it's going to show the same. The IPs will be there. But just know that behind the scene, it uses Route 53, because if you go here, the first time we created this, did you notice there was only 1 IP? But if I refresh this page, what do you think you're going to see? So let's refresh this so that you see what I mean. So you can see now there's now 2 records. There's now 10.10.21.9, and then there's 10.10.20.253. They're all from task IPs, right? If I go back and I reduce it back to 1 task, you will notice that this IP address was reduced from 2 to 1. But behind the scene, the service does not know. The UI does not care. The only thing the UI cares about is, I want to read the webhook service, and I want to go using webhooks or TikTok. And then on port 8000, and then there should be something behind the scene that is handling the traffic. I think I've been able to do justice to some of the things that I wanted to share, and I hope that you found value in it. if you watch, please practice. I think that's the only way you can sink this in. You just have to more or less like go through it, pick up a use case, try these things out, and do it yourself. If you don't do anything, it's going to be hard for you to replicate what I've just done. Okay, I think honestly we're good at this point. The next time we come, we'll look at the others, the second connectivity option that we have. Right now, we just did service discovery and cloud map, but really showing you the power of how this works with Route 53, and how behind the scene everything just fits together. So what we're going to do is there's nothing much I need to do apart from tearing things down. Okay, so we're done deploying stuff. What I'm just going to do is just pretty much tear things down, right? So here I'll just go and do Terraform destroy, and then for the other things I'll delete them from the console. But at this point we're actually done in terms of like really what I wanted to show you, the fact that you can have multiple services, right, and connect with them using a clean way. So it's good. This is going to delete the ALB, it's going to delete the repository. In this case, I think the only thing I might want to do is just get rid of the images in that repo. So I'm just going to go to ECR, container registry. Yeah, these images are here. I don't really need them. So I'm just going to, I think I can actually just do destroy. Okay, so I'm just going to do yes. Okay. All right, so we are seeing an error here, and it's basically, I understand, it says that a repository cannot be empty, so you cannot delete a repository when there are already images inside of it. But the good thing is that I think most of the things that were set up have been deleted. I'm very sure of that, because if we go to Elastic Container Service, for example, let me close this. I don't need this again. If you go to cluster, the cluster is gone. There's no, there is a namespace here. We'll clean that up from Cloud Map, but it's fine. Task definition, a number of them, but we don't really have a cluster. So this actually even, I think it's just because there's still some task revision. We'll just deregister them, right? So we will do deregistering. We'll go back here, check this one and deregister, okay? So these are just a number of cleanup steps you need to take. It's gone. If I refresh, no more task definition. The clusters themselves are gone. And then what we can actually now do, go to the repository, check the repo, and delete all the images, right? Because that's what it's complaining about. It says it's trying to delete that repo, but there's still images in the repo. So I'm just going to do that, and then we'll go back to do Terraform destroy again, and see that it does its thing again this time. So we'll do this. It's gone. Yeah, it's gone. So all the things that we deployed is gone. Let's just check. What else do we need to clean? Okay, yeah. So we need to go to Cloud Map. So if you remember, we created a namespace in Cloud Map. That namespace will be there. We can actually delete it if you don't need it again. It's associated with a service. It looks like that service is still there, but we know the ECS cluster is already gone. So I'm just going to delete the service. The service is gone, and then I'm going to delete the namespace. I'll delete it. What about Route 53? What do you think will be there? So let's refresh Route 53 and see what we have. Nothing is there. So the only thing we have is now the, what do you call it? The hosted zone. But remember, the hosted zone was created from Cloud Map. So I'm sure when we delete that namespace here, it's also going to delete the, what do you call it? The Route 53 hosted zone. But let's give it some time. So we're going to refresh this. It's still here now, but let's wait. It's going to take some time. So once it's done, we should be good, and then we can just revise the diagram again and see what we did, what we added, and how we've improved our life, right? So the namespace is gone from Cloud Map, and then I'm just going to go to Route 53. You can see the hosted zone is also gone. Cool. So if we go back to our diagram, what did we achieve today? We had this architecture, but we said that to make things quick, we just put the two containers in one task. And then we said today our focus was to split that. So what we did was each of them became an independent service that were backed by their own task and their own task definition. And then we used one of the service discovery options that we identified from the beginning. Here we're using service discovery with Cloud Map to more or less like create a namespace that is easy for us to deserve those services, right? Or for us to discover those services. So what it means is that instead of using localhost like we did before, we created something, a TikTok namespace, and we said webhooks.tiktok.8000/webhook, and we're able to reach out to this service. But the good thing is that now we don't really need to care about the tasks that are behind the service. Instead, the integration we set up knows when any of these tasks are unhealthy and it's going to take them out of the pool. So all we just need to do is care about this URL. Behind the scene, Cloud Map will do all the orchestration for us, register the healthy endpoints, remove them if they're unhealthy, and all that. And we already have a scaling system, a system that scales. And we saw that. We saw that we were able to scale to multiple services that were backed by IP addresses, and we were able to discover them by just doing webhooks.tiktok on port 8000, right? So I hope this has been useful to you, and I hope you found value in it. In the next class, we're going to extend this and also see how else we can do service discovery. But service discovery is a thing. It's not just with ECS. Every container orchestration tool you're going to work with would have service discovery. That's the only way services can talk to themselves. So it's a problem that different tools have a way of solving it, right? We just saw how ECS handles that for us. Cool. That brings us to the end of the class, like the class teaching you this additional improvements we've done to the services, right? And then we'll take it further next time.